Fine. Yes. Right. Welcome to my talk about live or atomic, no, online or live atomic updates. Prefer the term live to online, since online implies internet connection where you could do a sneaker update of the system and it would still be a live update if it didn't drop any services. My goal of coming here to talk today is to get a bit of buy-in from the idea that we need to have both online updates and live updates working together, and bounce a few ideas off people because I haven't got a complete solution yet. So let's get this clicky involved. First, what do I mean by live atomic updates? A live update means updating a system while it's running, so you don't have any service outage. So you serve your website, you don't get a connection failed because request came in while you were updating the server. Atomic is a bit more difficult to explain. You might have heard of Project Atomic, OS tree, things like that. You go from one version of the installed system to the other in one go. So you either get entirely the old version or entirely the new version, and not all the intermediate states in between where you installed this file, remove this file, change this file partially, so half of it's written and half of it isn't. In tradition, this is generally done, atomic updates are generally done by restarting into the new version, in my experience. So you get an atomic update, but not a live one, since you have to take the entire system down and bring it up again. Traditional embedded projects do this with A/B partitioning. So when you're running on partition A, you prepare partition B, instruct the bootloader to boot into B, and then reboot. So you're running B. There's a question? Yes? I'm getting to that at the end of this slide, so thank you for reminding me. Traditionally, you do this with A/B partitioning. You prepare the second, reboot into that. You can also do a rescue and a current one, where you reboot into a rescue partition and install into the current one. OS tree and Project Atomic do this by rebooting into a different hard link tree using some very clever technology. At my day job, I work on a project called BaseRock for a company called CodeThink. There's a few of us out in the audience. This has its versions of the software as different Btrfs subvolumes, and it reboots into a different Btrfs subvolume to do the atomic update. But the reason I've been investigating live atomic updates is because we don't want to have to reboot every time when we want to apply an update, because we want to provide a web server and apply the updates without dropping any connections, kind of thing. We want atomic updates because it implies being able to do system image-based versioning. So rather than having to work out exactly what's running on a system by looking at the entire package list, finding all the package versions, finding the version for each package, and ensuring that it's actually correct, you can look from the system image itself that this is version Web Server 1 or Web Server 2, and which helps in support, because if you know someone's running Web Server 1, you can know exactly what's going on there. Whereas if they were installing their own packages, they could end up with any combination thereof. We also want atomic updates because if you can't swap everything together at once, it's not reliable. If you lose power mid-package update, then you're in an inconsistent state where you could have anything going on and your system might not be bootable. There's tricks for ensuring that an individual file can be written atomically, so you don't see the in-progress work where you've written the first half but the second half is still from the old file. But if you have interdependent files, such as such as shared object libraries, you need to find a safe order for replacing them. For libc, the two support libraries that come with it depend on it, but they're versioned, and libc is generally good at backwards compatibility. So if you want to update these two, first you update this to the new one, and then these can be updated and safely use the new versions. And in the mid state where you've updated this one but not these, they're still using the old version safely. But you need to declare this dependency somewhere for it to work, which adds a lot of packaging overhead. And if this internal ABI isn't correct, then you're still in the state of when you do the update and something goes wrong, you're stuck. I'm not even sure glibc is good about internal ABI differences, since it declares a lot of symbols as glibc private. And it's obvious that if it's private, then nothing at all could possibly depend on them, so it's safe to change the ABI. Yeah. So, as any two files might need to be updated in lockstep for the system to be viable, we need some way of updating them all together. So I tried to come up with a way of doing an atomic file system update from the perspective of all the running processes. So there's two steps of that. One, you make all the data available such that everything can use it, and two, you actually make the processes use the new versions. In Base Rock, we have a copy and write file system. So if you want to update from factory to update one, we create a binary delta, and you apply it to that, and you get that. You then have to synchronize configuration, and all the actual state for users goes in there, but it's not so important. It gets mounted by the FS tab, and sorry about the mess. GraphViz was the most convenient tool. So those all get mounted like that. The root file system is that, and that has the FS tab describing how to mount all these. So the result is you end up with a file system with these entries, but I've put underneath where on the actual file system they come from, because the bind mounts make this not clear. Not so obvious. It's the mount route, which comes with Btrfs from specifying a different subvolume, but you can do it without doing that by mounting it somewhere else first and then bind mounting the subdirectory in. You can see this if you run findment or look at proc self mount info. There isn't a way to remount a subvolume to use a different subvolume, if that makes sense. You can't change what that points to by just remounting it. So instead, I create a duplicate mount tree, which looks mostly the same as that, except there's a change to what we're mounting. And then I do a pivot route to swap these two round, which means that from the perspective of someone looking at this, you've now swapped what everything is. You do the same kind of transition every boot when going from the init ramfs to your real root file system. Unfortunately, pivot route won't make all your existing processes use the new versions. It'll only change the calling processes root and current working directory. Or your old processes are still pointing to the old versions. So while you logically swap these two around, all your processes haven't noticed. It's enough for early user space where you're running in the init ramfs, since there's very few processes running that you'd need to migrate. But we want to do it for everything. So my proof of concept uses the ugly, ugly hack of using ptrace to make this process chroot, chdir, and reopen all these file descriptors. Yes, it's a very sick idea. And it's not an appropriate solution, since not all processes are p-traceable. Most processes aren't allowed to chroot. And they really don't like it when the underlying file changes. For an example, journald from systemd, when it restarts, it keeps its existing state around in a way such that it doesn't drop any connections by passing the file descriptors for each of the processes it's monitoring back to systemd, writing out state/run to say which file descriptor was which, and then when it restarts, systemd gives it those file descriptors back, and it reads from the state in /run which one it was. It works out which one it was by the stdev and stino fields from the file descriptor if you stat it, and if you do a reopen, those will have changed. So, ptrace is bad, don't. I'm just about to show you how well it works. Let's try and full screen that. This is a demo I recorded with the script command because I really didn't want to risk it not working. I'll specify how to replace the mount point when it runs. Fails to run first time because I forgot that to pivot root you also need to have non-private mount propagation. So there we go. You created the parallel mount tree back there. It's warning that all these processes aren't ptraceable. So it's not working all of the way down to there, but then it's got to the end after moving a few and has pivoted into the new one. And so it's gone off the edge, but just demonstrated that the version of GCC has changed between the old version and the new version. Don't applaud this. I'm going to have to throw this all away. Because it's doomed, because ptrace is wrong. I could improve it slightly by using rename app2. It's a new system call, and you can exchange two directory entries atomically. So you can completely swap them around, so you have a symlink to the old version, and the real version is a new directory. They see the new ones. It sounds perfect, but existing processes still have the old roots, even if you've changed the directory entry around. The reason for this is that processes refer to the file itself, not the path in the file system where it came from. So even if I were to use rename app to move everything around rather than the parallel mount tree I showed all the way back when, rather than this parallel mount tree idea, we'd still have to move all the processes and find an alternative to ptrace. We could try to add a new kernel interface for changing a process's file descriptors, but I have my doubts that the upstream guys in the Linux kernel would accept this because it's awful, awful, awful. And it still has the stat of this file changing in between running, so you're still going to break journald. But I've got a few ideas for things which might actually work. One would be file system transactions. There's been a few attempts to do something like this, and there's been at least 2 attempts to do it specifically for Btrfs. There's currently code in which lets you start a transaction and run some syscalls, and then when you end the transaction, all the changes have been applied atomically. Unfortunately, if you're not very, very careful, you'll deadlock your entire system. So, not useful. There was a patch as well to have a different way of doing a transaction where you provide a list of syscalls to run in the transaction, but that got rejected. And the suggestion was that instead you should have a way of merging to subvolumes. So it's like a Git workflow. You branch, you make your changes, then merge back in. Another approach would be to fake an atomic update by freezing all your running processes. It doesn't matter if it takes longer to do each individual thing, if you can at least make it appear that it's all the same for everyone. You can freeze a bunch of processes with a freezer C group. And to make sure that we've got something reliable all the way through, we freeze everything, create a snapshot, instruct the bootloader to use that snapshot if all goes wrong, apply the changes, And if it works, we tell the bootloader that, okay, you don't need to use that snapshot anymore. We're working with this one, and unfreeze. So if your power goes out while updating, you've still got a viable system, and in between, no processes have seen something wrong.
So you still need to twiddle the FDs?
Yep. But if you freeze everything, you don't need a single operation to twiddle everything round. So rather than replacing which directory people would use, you keep the old directories around but change the contents like you were doing a normal package update, which works by removing the files but leaving the directory tree still standing. My goal is to have something which isn't a regression on installing packages on the system. And if you have your root changing and your file descriptor's wrong, then you're not doing that. An alternative which gives up on the idea of updating all the processes together anyway is that rather than trying to update every process to use the new version of the file system, we just swap up which version of the file system it's using and have it restart all the processes in the new file system. This is not a completely terrible idea because you can make processes hand off their state to init and start again with the new state so you don't drop connections. But it doesn't work for SSH sessions because you'd need your SSHD to be able to look down into all your processes and work out how it needs to restart them to get them to work properly. Final approach would be to come up with a proxy file system that goes on top. So your processes interact with that, but you can have the proxy file system atomically swap which backing file system it should be using. And it can proxy the inode numbers so they don't change in between. I'm a bit worried about this one since I'd very likely to just end up finding more things which don't work particularly and end up with a big pile of doom. AUFS, the layering file system, nearly fits the bill though, because it does the inode remapping for you, and you can add a new layer on top, so new processes will see the new version of everything, but you can't remove the old version from underneath while it's still got things open on it. So you could, yes, make everything use the new version, but you won't be able to remove the old binaries from your system until you've effectively rebooted.
Can you use a seed root to like hold the state of the previous state as the new state and use that to kill off anything that's old, or?
Yep. After you've done the atomic update for every process, you still need to restart everything to make it use the new versions of the binaries, but you need to do that with package-based updates already. And cgroups would be a useful way to tell if processes are old, but you can look in proc maps to see which proc process ID maps to see which processes have old binaries still mapped in, so which ones are still running old code. And any other questions? Because I really went through that quicker than I expected. Yes, at the back there.
So, what I'd like to see is how this solves the sort of problems you're typically solving with an update. So, like for instance, you discover Heartbleed,
Mm-hmm.
so you need to restart Apache, right? So,
Mm-hmm.
so you want your Apache to be not vulnerable.
Mm-hmm.
So you do your atomic update trick,
Yep.
and hypothetically it works one day.
That is the plan.
You still have an Apache daemon process
Mm-hmm.
with the vulnerable libSSL paged in.
Yep.
So it's still running the vulnerable code until you restart that service anyway.
Yep. The point is,
So I don't really see how avoiding restarting the service for an update that to be useful requires you to restart the service. I don't see how that's useful.
it's useful for you've connected in with an SSH session and you're running a shell and you want to be able to still operate and see that the update has been applied at all. But yes, you would need to restart the new processes, and Apache does have a way of doing that without dropping any connections. It's got a graceful restart, which is good.
Okay, so anything that has the clever re-exec thing,
Mhm.
whatever trick uses, like Apache or the kernel, it can do that. Anything that doesn't have that trick
It'll have to be killed and restarted, yes.
needs a reboot or a small part of one anyway.
It's an individual process restart, which is a lot more lightweight than doing the whole system, but yeah.
The point is to avoid a whole system restart when you do an atomic update.
Or depending if you're deploying file images.
Right? For the small subset of your updates, where you can get away without a full system restart anyway.
I mean, here you've got a consistent file system tree swapped atomically versus depackage or if you want to do some big things incrementally. So if you swap all file systems, you still have the problem with running processes, right? So that's not changing. But at least the
I
file
guess the value
system
of
got
the atomic is not the value of the live here.
Yeah. The atomic is good, the live is a question.
Right. And at the back?
Yeah, my other question is about LD preload.
Okay.
The question is, when you take the address of the change of the files that you LD preload, and since replace the files, then you get welcome to an execution.
I'm not sure I follow you. Was the question that could I use LD preload to do the indirection so that processes get the new version?
So you're statistically notified that you're going to execute all files will be mapped.
Unloading a library basically doesn't work. Unloading a library is really cleverly designed to have you never take the address of anything.
So you're always going to restart anyway.
Yep.
So I haven't looked at it yet. So with atomic or implemented by Jenkins, where there is a symlink like
Mhm.
you suggested, like you suggested before. But basically this is like what you suggested in the third approach, where we are restarting the system that we don't keep connections unless my atomic. But we restart if any of the dependencies change. So if we see that a systemd service has changed to another because of one of the dependencies changing, then we stop it and we restart the new one.
Mhm.
So that's not flying. But that's at least something which is more or less atomic because it's more or less you still have to restart.
I looked at whether you could use.
Repeat the question.
I think the question was, Nix restarts processes by when it changes the symlinks for each of the package it is installed, it restarts any processes which were using things referred to the old path from the symlink, and whether that would make things better. I looked at symbolic links for constructing the file system in a way which you could atomically update an individual entry. If processes are referring to files after following it, then they're still using that file, and replacing the symlink means you have to replace everything. You have to restart the process. But yeah. But the problem is if you have a big long tree of things like you need to replace the entire root directory as one go. Whereas I want to have the entire file system updated at once because there's different parts which interdepend on different versions, which I think Nix gets away with because each component refers to a specific version of a dependency. But I want to update everything so that the interdependent parts are updated in lockstep. Whereas with Nix, they replace a symbolic link and the default version of the binary is changed to a new version. We're out of time. Another 5 minutes. Yes?
I don't understand why you need to let the processes use the new root file system. I mean, any files they have already opened, why can't they just keep them open? You can keep the old file system around until you reboot. So
They're still using the old files, which is exactly what happens with package-based updates. I want them to use the new version, so if you...
But I mean, the files which are open, they can't use a new version because they will have seek to a wrong location. So does it make sense to use a new version of it? I mean, any library which has open after changing your file system, it cannot use the new version of that library, of course, without restarting.
Yeah, but it can gracefully restart in such a way that it doesn't drop any connections and it will eventually see the new version. I'm not sure I've got the point of your question, sorry.
So any process which is not restarted, which you want to hand over to the new root file system, if it's not restarted, it probably means that the underlying file hasn't changed, right? Because otherwise you would have to restart it to make it actually use the new file.
Okay, so I think, can I just say something? I think what you're missing there is that what you're trying to do, you've got a new atomic version of the file system, and then you want to hand over, so you've got graceful handover of any open connections to the new system, right?
Yeah, so you can have graceful handover either by restarting the process.
Well,
Maybe
that's
just
restart a process doesn't give you graceful handover.
Yeah, if it doesn't do graceful handover, then you have to keep the process running. But then this will not work if the process has any file open which has changed. I mean, if the first is a file open and it's seek to position 5,000, and you change that file underneath the process and insert a byte in the beginning, then it's going to spin all
I
horrible.
don't think that's what he's talking
Yeah, so
about
that's
doing.
why.
Yeah. You're asking for something that he's not doing. He's not changing the files underneath the process.
So what is this migrating the file descriptors then?
It's telling it that when it reopens, it's telling that it will use this new directory rather than any existing files itself. I didn't want to go as far as the open file descriptors for actual file content because package-based updates already have that, and that's beyond the scope of what I want to solve at this point. I don't want it to be worse than a package update. I want it to be better in the way that you don't get any intermediate states where it could reboot and the system be broken.
Does this stuff only matter for the shell sections you've got open? So you can use the ptrace approach. I mean, any other services, you're either going to be restarting them or telling them to gracefully hand over to a new instance of themselves. So you don't need to do the FD twiddling. The only reason you're doing the FD twiddling is so when you've got an SSH session into a box, your SSH session transitions into the new version of the operating system.
It also matters for how some processes gracefully restart. They might decide to re-exec rather than how the systemd approach would work by you hand your file descriptors back and you restart. If you re-exec, you'll still have the old root directory, which is pointing to the wrong thing, and all your file descriptors pointing to the wrong thing.
So is it just re-exec that you need to worry about?
That's one of the things, and there'll be probably others as I go to find them, but I haven't found all of the things which could go wrong. Any last questions? Great, thank you. Oh, one. Sorry, could you speak up? I'm sure a lot of people want file system transactions, and if we can get them working, this would solve this. But all the approaches I've seen haven't gone anywhere, which is why it's in one of the future things to investigate to see if they can be done properly. Thank you for the question. Oh, one more.
Could you move the old processes to read-only snapshots? Just keep them running for the time being.
Yeah, we couldn't, and make the old version there running read-only, so at least they're not doing any harm by still running. But we do want to migrate them to the new version, yeah.
And then kill them.
Yeah. Well, thanks for all coming. See you talk.